Hi everyone. So I'll be discussing this problem called Serval and string theory. In this problem, you're going to be given a string and two integers called n and k. What you have to do is create. Let's say that string given is this string. Now, what you have to do is um, perform some operations such that you reach a point where once you reverse the given string, let's say this string is S, and the reverse of this string is called RS. Once you do that, after applying some operations, uh, that string, the reversed string, should be lexicographically greater than the previous string. Okay, so this function should this condition should satisfy here. And what is the operation that you can apply to it? And the output is either yes or no, whether you can actually reach this point, you know. So what are the operations that you have an option? Well, the operation is defined as you cannot limitlessly apply these operations. You can only apply these operations at most, I guess, k times. Um, so the k value can also be 0. So that is another point to note. But what is the operation? The operation is actually you take two integers, two different indexes from that string, and you can actually swap them. That's it. That's the operation. Nothing else. Nothing complicated. You just swap those two different index numbers. That's an option that you have. But the question is, how are you gonna be able to reach the solution? So my approach was that I actually don't need to care about whether k. I can actually, if there's a solution, I can actually come up with the solution with k. If the k is, I don't need to worry about multiple k values. If k is at least 1, then I can actually guarantee whether there exists a solution or not. So I'll be dealing with only these two cases, whether k is equal to 0 or k is equal to 1. Now, for k equal to 0, initially you check that if k is equal to 0, then there's no operations that you can actually perform. Well, in that scenario, what you would do is you would simply, as you don't have an option, what you would do is simply take its reverse, just like that, and then just check whether this already existed or not, which means whether initially the string is in such a way that the reversed lexicographic operation is actually greater than the initial string. So as you don't have an operation to perform, you just do what you have to do without the operation, without applying any sort of operations, as you don't have any option left. So that's the k equal to 0. I'll go into the details in the code section where you would understand about it more. But what if the k value is not 0, it's greater than 0, then I don't actually care about what is the value, because if it's greater than 0, I can guarantee if there's an answer exist. If there's an answer exist, then I would simply say yes, otherwise no. Now, how can we actually guarantee if k is greater than 0? How can we actually guarantee whether I have an answer? Now, the way you can do this, or the way that I thought about it, is, you see, you will check the minimum character, and you'll find out the minimum character in this string and the maximum character in this string, and also you will track their indexes, where they are actually situated. Why it's needed, why it's required, because we want to make sure that we have an answer. So if somehow I actually make this first index as lexicographically the minimum character, if I could bring the lexicographic minimum character out of all these characters into here, then I might have a chance that I might get, then I might have an answer, but I'm not guaranteed. Still, I'm not guaranteed. Why is that? Okay, let's just take that thing and apply the operations. I'm talking about the minimum. I'll check. Okay, for this example, I'll check what is the minimum character. I see the minimum character is already here, so I haven't. I see I don't have to, swap these things. It's already in here, but it could have been in here or here, but I would have swapped these two characters. And then you see I have the minimum character in here, so it's actually, the answer is yes, because if you reverse it, what happens is CZ CBA. So that's the case. That would happen. And you see, if you compare, this is less than this lexicographically again. So that's one way. And now, what if? Now you might say, oh, we have an answer if we just calculate the minimum character and its index and just replace it with the first index. But I also talked about, you also need to care about the maximum character. Why is that? Why I'm saying that? Because only tracking the minimum character and its index, it's not going to give you an optimal answer every time. What if the initial string S was something like that? What if it was something like that, where the minimum character and its index is both in the first index? The minimum character is both in the first index and the last index. Now, what happens? This would actually cause a bit of a problem. Might cause or has the possibility to cause a bit of a problem, because once you reverse it, once you do, okay, let's just take this example. Okay, for this example, you wanted to, let's say, this was, this is the example that you're given, and you take the minimum character and its index, and you take it here. But the catch is that the minimum character is also in the final index too. Now, once you reverse it and you try to compare, what happens? What happens is that you don't get the lexicographically minimum. This is not lexicographically minimum. It might happen that the minimum characters also exist in the last index. So you have to check for both the maximum and the minimum. If you just check for both, you guarantee that there could be an answer. Why is that? Now let's look at this. I will also, at this, as well as along with checking the minimum character, I would also check the maximum character. What is the maximum character here in this string? You see, the maximum character is B. So what you would do, for one case, you will check the minimum character, you will swap it with the first index, and you will check whether there is an answer that exists, meaning comparing with whether it's lexicographically less than or not. If it does not happen, what would, as in exactly what happened in this case, what you would do, you would take the maximum character and you would swap it with the last index. Why is that? Because we're trying to maximize the answer. We're trying to maximize the possibility of the answer. So what would happen? The maximum character gets swapped with that, and you have a new string of this. You've applied only 1k. Just remember, you only need 1 if it's greater than 0. You don't need anything else. Now for this string, if you try to reverse it, what happens? B, A, double B, and then A. Now, does this string lexicographically, is it less than the following one? Yes, definitely. So that is why we're also checking for the maximum index and swapping with the last index. we're checking the minimum character, and we're swapping with the first index. And that is why we can, and that is how we can actually make sure or guarantee whether there's actually an answer exist by tracking these answers, these two values and indexes. So I'll take you to the code section to make you understand more about the solution. Okay, this is the solution here. This is like finding out the minimum characters and the maximum ones and their indexes. Now for k equal to 0, you don't have an option. You just do it. You just reverse it. You just compare it. That's it. Otherwise, you call these two functions. So, both of these min and max character finding and swapping, they actually perform same operation. So I thought, why not take them into a same function? That's exactly what I did. And it would increase the more readability of the code too. So you see, this each and every function is actually what it's doing. It's taking a character and its corresponding index, and also taking another index, which is which position we want to put that index with where that character was in the first place. So it's basically that swap operation that we talked about, and yeah, that's the same operation like that, just to try to figure out whether we have an answer or not. If we don't have an answer, we just say 0. Otherwise, we say 1. Yes, we have an answer. So that is exactly how you can actually, solve this problem. So, yeah, thank you very much. I really appreciate it. Yeah, goodbye.